So talk JWAT, JSON Web Tokens. So are a lot of you. So I'm a security engineer. As Austin said, I'm based in Melbourne, as you can probably tell from my accent, mate. Anyway, so I do like a bit of security consulting, engineering, code review, pen test, a bit of everything. And I also got this amazing website to teach people how to learn web hacking, kind of like HTTP parkour. So, tough crowd. Hey. Anyway, so basically when you're teaching web application hacking, you got to get good examples. And you can make up examples, but it's pretty bad because people have to learn your example and then translate that into the real world. And some of the crypto bugs you can find are really like the future of web hacking because more and more people know how to fix SQL injection, cross-site scripting, but all these like applied crypto bugs are really interesting. And I was struggling to like create good example, and one day I found JSON Web Tokens. And they are amazing. They bring so many beautiful bugs, you're going to be amazed. So who is using JWT here in this room? That's a lot of people. So you probably see them all, like if you look at HTTP traffic, you probably use JWT without knowing it. People use them for API, people use them for mobile apps, people use them for everything. And they use it OAuth, event session, or password reset as well, not a really good idea. People who care about being stateless across data center, instead of having a pool of sessions, they use JWT as well. So a lot of people are using them. So some acronyms I may use. So JOSE is JavaScript Object Signing and Encryption. That's the name of the working group and a superset of all the JWT. So JWT or JWT token is what most people use when they name JWT, but it's actually most people use JWS, JSON Web Signature, because they use signed token. Only few people use JWE, unless you're dealing with like MasterCard, Visa, these people do, but most people use JWS, trust me. JWK for JSON Web Key, just a way to put a crypto key in JSON. We're going to see some of that. And JWA for the list of algorithms that you can use. So if you're a fun person like me and you like to read RFC, you're going to come across a lot of those. So Crypto 101, I'm going to go slowly because there may be some pentester in the room. Sorry. So encryption gives you confidentiality, and signature gives you integrity. And there are two different things. If you want to make sure someone didn't tamper with data, you need signature. Encryption, unless you're using some cipher that provides integrity, does not provide you that. Today we're going to focus on integrity. So there are multiple ways of signing data to make sure no one can tamper with them. The first one is HMAC. So it's basically a construction on top of hashing, like MD5, to create a signature. We're not using just raw MD5 because that's subject to length extension. So people use HMAC, which is basically like a hash of a hash. And yeah. Or you can use private key, and you have like your public key, your private key, you got PKI to manage, and that's using Asymmetric. And JWT support both. So when you're using HMAC, and you sign with a secret, you create some data, you sign it, you pass it to someone who is going to verify the data, verify the signature, and both of you need to have the signing key. You need the secret, which is not awesome. So people are using private and public key. So you sign with the private key, then yeah, I got it right? Yes. Need to be careful, you never know. And then you pass that to the verifier, and the verifier would say, okay, I got the public key, I can verify this data. Yeah. So now the JWT format. Let's just dive in. So first we got JSON. You can put a bit of everything in JSON, like name, like string, int, array, hash, whatever you want. I was really inspired the day I wrote that slide. And so you have three parts in a JSON Web Token: the header, the payload, and the signature. There's a dot between those parts to make sure, like, when you verify, when you're getting a token, you know where to split, right? So you say, like, okay, I'm going to split with the dots. So it's pretty easy. And they're really easy to recognize thanks to that. And they start with EYJ, because that's the base 64 of a curly bracket, followed by a double quote. And since that's JSON, that's how you can recognize them. So if you see that somewhere, EYJ and dots, you are dealing with JWTs. And the signature doesn't start with EYJ because it's not JSON, it's just crypto. Well, yeah. So the header and the payload are base 64 encoded JSON, and the signature is also base 64 encoded. Base 64 encoded. It's actually base 64 or URL encoding without training. So basically, we remove everything that doesn't play well with HTTP, like equals, like slash, like plus, because plus is the encoded version of a space. So we remove all of that, and we say, like, okay, we got to a new token. And that's why when you decode them, the base 64 may look funny, and you may be missing a curly bracket at the end. That's because you're using a classic base 64 instead of using base 64 decoding URL ceph without padding. All good so far? Thanks. So as part of the header, the blue part, we got an algorithm. So that's to tell the person receiving the token, this is the algorithm that was used to sign the token. And you also get a type to say that's a JWS, so a signed token. In this example, for example, it's HMAC 256, HS for HMAC, and 256 for 256. A lot of different algorithms are supported. So HMAC, RSA, elliptic curve, RSA with, what's the name, some weird padding, basically RSA, but with a different padding method. And this guy, none. We're going to get back to that in a minute. And why is it interesting to have multiple algorithms? Because you can be crypto-agile, which is a terrible idea, but people used to do that a few years ago. So imagine you got like one client and multiple services. So if you use HMAC, everyone, so for example, the first server is the one at the top, signs something, pass it to the client, and the client call an API with the service at the bottom. Everyone needs to get access to this secret to be able to verify the token. So if one of your server gets popped, bang, it's game over because all the secret, or the one secret is compromised for everyone. So you need to rotate it everywhere, and even if that server at the bottom wasn't critical at all, that was probably like just, I don't know, doing something really silly and nothing important, because it got compromised, the secret is compromised for everyone. And you get an incident, you rotate your key, bad day at the office, yeah, blah-de-blah. If you're using asymmetric crypto, so first what you can do is put the same private and public key everywhere, which is cool, but you're just back to this case if someone gets popped. So this is what you do when you do like elliptic curve or RSA or things like that. What you can do is be a bit smarter and say like, okay, I got these trusted services, for example, the one that does authentication, and only this guy will be able to sign token, and everyone else will be able to consume the token and verify it using the public key. And so if one of your server gets popped, someone still has a shell on your box, but at least you know that your secret is safe and you don't need to rotate the key and blah, blah, blah. So that's why there are multiple algorithms. And since if you're using RSA, you can even do that in the browser because it's a public key, so you can provide it to the client and do some checks in JavaScript. Because again, public key. But why doesn't everyone use RSA? Because RSA is a bit more complicated for people to manage two keys instead of one secret. And second thing, it's a lot more resource intensive. So if you're scaling like to the level of like million of users every day, RSA can be a bit hard to do. Trust me on that. The payload. So in the payload, you can put everything you want. That's up to you to say, OK, we can put like a username, we can put age, we can put the roles, everything. That's up to you. You do whatever you want, except you have claims. So they are registered keyword to say, OK, this is, for example, the expiry of the token. This is when the token got issued. So many more claims. So the issuer, the subject, the audience, the GTI for the claim ID. So people use claim ID to avoid people like replaying. So to avoid replay attack, you get like a cache. You issue token with a short-lived token, and you have a cache on the server side that is going to keep the claim ID so you can't replay the same token again and again. Expiration and not before or issue at. Issue at is really good because imagine you have like a lot of microservices, they play together, and then you have like these microservices that takes like 3 days to process a request. If you use expiry, your token will have expired before you're going to use it. Where if you use issue at, you can say, OK, all my microservices are going to trust the token for 24 hours. But my asynchronous microservice is going to trust that token for 3 days or 5 days. So that's why issue at is really awesome to do that. So how do you create a token? You create a header, you base64 encode it, you create the payload, you base64 encode it, you put them together, you sign the result of header dot plus payload. So even if we're going to use the header for the verification before we verify the signature, it's still part of the signature. And that's something a lot of people miss. And then you base64 encode the signature, you append a dot, and you put the signature, and you got your big token. How you verify a token? So that's where it gets interesting when you want to attack a JWT implementation, because that's where you want to find bugs. So the verifier will take the token, split it into 3 parts based on the dots. It's going to base 64 decode each part, or depending on the implementation, just a header. Then it's going to pass the JSON for the header and the payload, retrieve the algorithm from the header, and then verify the signature based on the algorithm, and then verify the claims. So if you see, like, there are 6 steps, and this verification of the signature is only step 5. So you got a lot of attack surface before that. So a lot can go wrong. And keep in mind as well that multiple systems can issue tokens. So if you're doing testing, pen testing or bug bounty, and you have like 10 microservices, one of them may be doing the right thing with the token you're sending, but another one here may not be doing the right thing. So make sure you test all of those API endpoints. Token can be used by multiple systems, and all these systems can use different libraries. You can have stuff in Go, in JavaScript, in Java, in everything. So you may have different bugs. So when attacking JWT, your main goal is to bypass the signature mechanism. And we're going to do just that. So first, what people do is they don't check for the signature. So basically, for example, that's a JavaScript library. They have 2 ways of, when you have a token, to get the data out of it. One is decode, and one is verify. And unfortunately, way too many people use decode. So they end up with a token, and it works really fine until someone starts to messing with the payload and change the username from hacker to admin, and the admin. And, or people do some testing, and then they forget to put that test back in place. It's a real check back in place. So it's happened pretty often. And again, if you got like a lot of microservices, you just need one to not check that properly, and you can do bad things. So exploitation, you get a token, you decode and tamper with the payload, and you send the token, and you profit, and it's done. Pretty easy stuff. So now the non-algorithm. As I said before, we're going to go back to this guy. So as part of the JWT RFC, they got this non-algorithm, and that sounds pretty silly, but it's just basically like unsigned token. But a lot of people use that, for example, when they're debugging stuff. Like in OpenSSL, you have this null algorithm for encryption, so you don't have encryption, so people can debug stuff. It's the same thing. And like with OpenSSL, people forget, like back in the day, people forget to disable non-algorithm. So basically, you have a token that is not signed. And the problem is that it's not the developer using the library that creates the bug is in the library itself. So that got fixed, but that made a lot of noise like 2-3 years ago. So exploitation, you get a token, you decode the header and change the algorithm to none or none, depending on the backend, because some support none with uppercase N, some need everything lowercase. I think the RFCs say you should support everything, but yeah. And then you decode and tamper with the payload, and then you keep or remove the signature. Depending on the implementation, you may need to remove the signature, or you can just keep it. You need to try. And then you profit. Everyone is feeling all right? Sorry, I'm doing all the talking today. It's pretty boring. Actually, I don't need that. So here, I'm logged in as hacker. You can tell that I didn't update Chrome. You know, like, I get my token, so that, as I said, I didn't lie. It starts with EYJ. Can people in the back see? It's all right? Thanks. So, gonna go there. So here, maybe a bit bigger. So algorithm, type JWS. Yeah. So what I'm going to do is I'm going to take that and base64 encode it, except I'm going to change algorithm from HMAC to none. And I got my new header. Now I'm going to play with the payload, because it's pretty boring to hack stuff if you stay the same user, right? I've got bad fingers today, sorry. And then I can see my login, and I can see where the token was issued. So I'm going to go the same thing. I'm going to change my username to admin. I'm going to keep that guide just in case it matters. And as I said, about the padding, you can see here that it's missing a curly bracket. That's because I'm using traditional base64 instead of using base64 URL safe without padding. I'll make sure I got everything right. Computers not for everyone. And, okay, I got my token. And I'm going to curl it. That's the name of the cookie. Might be. And then I'm going to connect to the same server. Part of it is missing on the, yeah. That's a bit better. 8E. And hopefully, if I did not miss anything, yeah. So, you are not logged, so I missed something. Because I kept the signature. Oh, no, that's part of the, you need to remove them as part of the padding sometime. See, it's because I kept the signature. And now, oh, God damn it. Why did I mess up? No, I don't think that's that. Oh, that's a good start of the day. So I'm going to go back. Okay. Yeah. Okay. That should work. Is that right? I think I'm going to move to the next one. Still got plenty of time, though. That's the easiest one as well. I don't know. That's terrible. Or maybe I messed up that part, and that's actually. Don't go, people. Stay here. I swear it's going to be good. It's going to be hacking. Yeah, okay. So I'm going to go back to this one later. The funny thing is that I was outside redoing it, and it just worked, and now it doesn't work. You don't have to believe me, but I swear it was working. Sorry? Maybe. Okay, I'm going to jump to the next one and come back to that to show you that I can still do some computer stuff. So another thing is using trivial secrets. So people sign using HMAC, but they use like bad secrets. And, sorry. And the security of the signature relies on the strength of the secret. And the really interesting thing that people don't think about is, as an attacker, I'm visiting your web application once, I get my token. Then I spend 3 months, 6 months, a year offline, cracking your secret using hashcat, for example. And then I change my username to admin, and I come back just one other time to your application, and I'm an admin. So you get nothing in your logs. And as people say, no logs, no crime. Some law enforcement people here? No? So yeah, and that's, for example, one example of someone doing like a boilerplate, like putting like libraries together, and that's how, if you Google, like if you GitHub search that line, it's pretty common to have that. So by default, in every environment, they use secret, regardless of the environment, unless it's production. And when it's production, they're going to use the JWT secret. But it means that if you don't run, if you just like make a typo or something like that, or forget to be in the right node env, you're going to use secret, and then you're going to get in a lot of trouble. So exploitation, you get a token, you breed for the secret offline, you come back 5 days later, 10 days later, then you tamper with the payload and you reassign the token because now you know the secret. And yeah, you're done. It's a good thing as well that sometimes the secret can be leaked by the application in stack trace or something like that in error messages. Now we're going into the juicy stuff. Algorithm confusion. So the sender controls the algorithm used. So when I'm trying to attack an application, I get to pick what algorithm is used to sign the token. The server side may reject it because they don't support this type of algorithm, but I get to pick. And if you're using RSA, you're going to sign the token using your private key, and you're going to verify it using your public key. But if I am an attacker, I can tell you, okay, actually, that's not, and I got access to your public key, which I can get from a mobile app, I can get from like some JavaScript, anything. It's a public key. So as an attacker, I can tell you, okay, actually, you're not using RSA anymore, you're using HMAC. But when you get that token, you're going to say, okay, verify HMAC, and the secret for the HMAC is the public key, because you thought it was RSA, so your source code is using the public key to verify. But thanks to my malicious token, the application is now using HMAC to verify using the public key, and since everyone got access to the public key, they managed to get in. And then they change the payload. So basically, blah, blah, blah. You can get the key from here. So you get a token. It's signed with RSA. You only have access to the public key. You decode the header. You change RSA to HMAC. Then you tamper with the payload, and you sign with the public key. The thing is that you need to make sure you read the key programmatically. You don't copy-paste it, otherwise it's just going to break. OK, so we're going to try demo number 2. Hope I at least managed to nail 1. Good start. Let me clean up. OK. Just want to remove it. OK. My goal is to log in as admin, and the application gives me a token already. And as you can see, so I'm going to go. That's number 3, sorry. That's the one I want. OK. Explore. So what I'm going to do, so I download the public key. I'm going to get a token from the application. So I already copy-paste it here. And I don't care about the signature, so I left it on the side. I'm going to split based on the dot, so I get the header and the data. I'm going to change HMAC. I'm going to change RSA to HMAC. And I'm going to change my username from test to admin. Then I concatenate the header and the data. Then I do a HMAC with the secret being the public key of the header and the data. And then I concatenate everything together. I use a URL-safe encoding. And I should get a nice token. Now, I'm going to use the same thing because it worked really well before. And oh, I'm an idiot. I know why it didn't work. 3. Thank you. So I think that's exactly what I did wrong with the previous one. Yeah, you are logged in as admin. I should just screen cap it. Woo! So the previous one, I just used the wrong port. I should have put name or something like that. So it was on 81, and I used 80, I think, or something like that. Anyway, I swear I can solve it. OK, so key ID injection. So as part of the header, you can have a reference to a key. It's named key ID. And this key ID can be, time-wise, we're doing OK? Yeah, I think. It's a reference to a key. So what people do is they can put, for example, the key ID as a file name or a value in a database or something like that. And when you get a token, you base64 decode it, you JSON parse it, and then you take the key ID, and you use the key ID to retrieve the key. And you can tell I didn't say you verify the signature, because you verify the signature after that, because you need the key to verify the signature. And the thing is that that parameter is injectable like everything else. It's not protected by anything. So you can just put your injection in there and try to do like directory traversal, code execution, or SQL injection. So again, you get a signed token containing a key ID parameter. You decode the header and change the key ID with the SQL injection payload for this example. Then you tamper with the payload, and then you send the signed token using the return value from the SQL injection. That's the cool part. So you're going to do an SQL injection, but you don't want to retrieve the database because that's boring. What you want to do is use the return value from the SQL injection to sign your token. Since you can predict the return value of the SQL injection, you can predict the key, and you're going to use the key to do that. I told you, cool crypto bugs. Why it doesn't work? I think my computer just freezed. Hello? Not a good day for demo. Yeah. Wow. Okay. Started. So that's annoying. Okay, so we're gonna hear like, yeah, I lost the keyboard. Wow. Okay, so it's gonna reboot in the meantime. I'm gonna go walk you through the next one. So the next one is a bug in, hopefully it's gonna reboot. The next one is a bug in Cisco JOSE JWT implementation. And it's quite interesting as well. Gonna log in. So what happens is, as part of the header, you can put another thing, named a JWK. So you can put a key inside the header. Obviously, if you're verifying a token, you should trust this key but verify it, right? So what happened is that in this implementation, so the JavaScript implementation, what Cisco did is they trusted the key inside the header. So it's like, I give you the token, I give you the key that goes with it, and I sign with the same key because I know the private key. And the implementation, yeah, you shut your computer because of a problem. No, shit. Sorry. And I think it's recorded as well. Good day in the office. So yeah, so what you do, okay, and Docker restarted, and we're gonna get there. Okay, I'm gonna give a few seconds to Docker too, and then I'm gonna go through the demo back. Please don't freeze. Okay. Docker needs to start, so we got a good 10 minutes. Okay, so let's go through the slide while Docker is doing his Docker thing. So that's what a key ID looks like. So basically, we're going to put that inside the header with our RSA key, or just the public part of the RSA key, and tell, OK, verifier, this is my token, and I signed it using this key, and you should trust this key. Pinky promise, it's good. And then the server will use that. And the amazing part is that people had this issue without using JWK at all. It was part of the library, and they got that for free. So yeah, and what you do, so you get a token, you decode and tamper with the payload, you generate an RSA key, then you add modulus and exponent to the header, and use that to RSA sign the token, and then you sign the token with your RSA key. Don't crash a second time. Docker is still starting. OK, we're going to go through the slide and do the demo at the end. Nice. So conclusion. We're going to get enough time to do that. So use strong keys and secrets. Don't store them in your source code. That's pretty common with people. Like, we got everything together, so one developer left the company, and he got the secret, and then he can do whatever he wants. Make sure you have key rotation built in. That's really easy to bake key rotation in something when you're building it, but then put key rotation afterward. It's a bit of a nightmare. Review the library you pick. Try to find like keys library, like keep it simple. Make sure you check the signature. That's probably like if you get out, just like look at your source code and make sure you check the signature. Make sure your token expire as well. You don't want to have like to rotate keys because your token lasts forever. Enforce the algorithm so you can't have the confusion attack. JWT are kind of complex and really insecure by design because they're so complex. Pazeto is like an alternative, but not many people use it. They introduce a lot of really interesting bugs. And yeah, make sure you test for those because plenty of bugs around. Let's talk about. Not my lucky day. So future things. So back when I started looking at JWT, like probably 2-3 years ago, there was this amazing thing in the RFC around JKU and X5U. So basically, you're going to tell in the header, this is a link to the key you should use, which looks like a really, really bad idea. And I thought, oh my God, that looks amazing. It's going to be so many bugs in that. And people were not using it 2 or 3 years ago. And then I looked again a few months ago, and people start using it. And they mess it up. So basically, you get an HTTP request with a JWT. You pass to extract the JKU header. Then you fetch the key from a trusted server or from localhost or something like that. And then when you get the key, you pass it, and you verify the JWT signature using the JWK you just downloaded. So pretty simple, but unfortunately, people are terrible at filtering URL. Like server-side request forgery. Like I looked at a JavaScript implementation where they always fetch the key. Even if it's not trusted, they fetch it, and then they tell you, OK, the signature is fine, but that URL is not trusted. So you can just like server-side request forgery, server-side request forgery inside the infrastructure for free. And then you can maybe get lucky. Authentication bypass, obviously, because then if you can get the server to fetch your key, you can sign whatever you want. And chaining bugs together. So like, for example, if you got an open redirect, you can get, with the JKU, you can get, and it's filtered properly, you can use the open redirect to redirect this application when it's fetching the key to get to your server. Even if you get like an initial filtering here, you bypass it with the open redirect. Or you can even use a header injection. So if you got a header injection that is part of the whitelist, you can just use that to echo back a JWK, and then it's going to use that key to sign things. OK, now we're going to get back to the demo. Yay! Docker is starting. OK, so it's going to, I should have started. So, OK, a lot of upgrade today. We said JWT. Yeah, so that's the one with the speed injection I was talking about. Maybe a bit bigger. So what we're going to do is, OK, I'm going to say my algorithm is HMAC because it's the thing I know and it's using. Then I'm going to say, like, OK, basic SQL injection that returns instead of returning the actual result. That's why I'm using ZZZ. So this way, it's not going to return anything on the first row. And it's going to return AAA. Since the SQL injection returned AAA, the new key is AAA. So what I just do is use a HMAC with AAA, so pub, and sign the header and the body, and I'm in. So if I run that, I get my token. I kept the equal sign, but that should still work, because today is my lucky day, as you can tell. Yep. And yeah, I'm logged in as admin because I managed to use the SQL injection to return a key that I know. And this way I can sign with the same key, which is pretty cool when you think about it. And then, for the grand final, better not miss this one. So then the last one, the not Jose. I'm going to clean up that thing. Actually, I need that. So what I'm going to do is, I'm going to create a private key. So I'm going to regenerate it because otherwise you won't trust me. And then from this private key, I'm going to get the public key. From the public, I'm going to get the modulus and the exponent. And I'm going to put all of that together in this JWK header. This part here. I keep the key ID because that's the one I had from the application. And the data here is just like base64 encoded admin because this application doesn't use JSON for whatever reason. And I'm going to sign with the private key because that's my key, right? That's the one I got locally. And then I'm going to send this big token to the server, and the server should be happy and thank me for it. for it. So I got this big token, because obviously, first you got like a RSA signature, big, big, big. Then you got the JWK with like exponent and modulus, so big, 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 and you send that to the server. Would be good for the last one to work. You are logged in as admin. The keys. Woo! And I got still a bit of time. Ah! So I'm going to do the first one so I can prove you that I can do it. First, I'm going to make sure I got the right port. Yeah, so that's the one I want. I'm going to register, hacker. I messed it up. Cool. Don't remember that. Oh, damn it. Do demo, it's going to be fun. Great idea. So I get my token. I'm going to open the best editor in the world. I'm going to get that part. Oh, 64-D. So I modified the header to put none. Now I'm going to modify my username. When you're actually testing for this kind of bug, it's usually a good idea to not change your username right away. You first try to bypass the signature, and then you start playing with your username. Less room for error. But since you can tell I'm a professional, I'm going to do both at once. If it doesn't work, I'm going to look so bad. OK. Oh, thank you. A few people are following in the room. OK. OK, and then, and I get my new token. T1. Woohoo! Woo! Thank you. And still got 2 minutes. Over, yeah, 5 minutes. Yeah, time zone. OK, so I got still 5 minutes. So I'm going to go back to that, yeah, because that's actually pretty interesting. So yeah, and people don't use X5U, which is like JKU, but with a certificate, because keys are hard enough. But if you look at, so that's the library I was talking in JavaScript. Oh, I don't have internet. But yeah, so this library in JavaScript, they do like all the fetching all the time. But like, the good thing with that is people, so for example, I was looking at some source code this morning. Oh, not this morning, yeah. And what they do is they use start with to verify a URL, which looks on paper pretty good, but it's actually a pretty terrible idea. So let's say your URL is HTTPS, another bug, ptl.io/trusted. And you're going to use like start with, because you want to make sure that the URL starts with something, because you have a key that is named, I don't know, key1.json, and you have another one that is named key2.json. The problem with start with, and if you're not careful, and not trusted.json. So yeah, that's the problem with start with, is that it's a bad way to verify a URL. So that's why you should have hard-coded value or things like that. And a lot of people got that wrong as well. So as part of the RFC, you're supposed to always fetch the key over TLS, because otherwise someone can man in the middle of the connection and return another key. The problem is that most people understand, or few people understood that as you need to make sure the JKU starts with HTTPS when you create the token, which is not the same thing as verifying that the URL starts with HTTPS when you receive a token. Because an attacker can, even if you use HTTPS URL for your keys, he can say, okay, I'm creating my malicious token. I'm going to get it to start with HTTP. And since I can man in the middle your application, I'm going to return a key before the real server returns the real key. So you need to make sure, like, if you're using JKU, that it's actually doing the fetching of the key that you're enforcing TLS. And I don't know if that's about it. Sorry I went a bit quick, but yeah. And sorry I messed up the demo.